We're really trying to understand the fate and transport of these PFAS class of chemicals. Where do they go once they're in the subsurface? How fast do they move? And when does it become a problem?
What we're finding out more is that a lot of these compounds do stick around fairly close to where they're being released. So that is a potential benefit if you've got these polychlorinated compounds. They might not necessarily be converted all that rapidly, and they might stay in a relatively close proximate area to where they're released, such that that helps to mitigate some of those potential concerns with either conversion to this sort of dead-end perfluorinated state, as well as the potential for migration, because in that polyfluorinated state, they may be less mobile.
We use computer models to understand that fate and transport and the dynamics of that movement. And there's some that are very simple, some that are much more complicated. The image is really showing the extent of a PFAS plume at a site that we characterized. And it's a 3D picture of where the contamination is, really where the boundary of the contamination is. And everything within that certain zone are at concentrations above these action levels. And so we've got to understand the fate and transport of what will happen to that in the future.
In some ways, our job is sort of like a detective. It's trying to figure out, can we understand where the PFAS that's present at a site came from? Is it related to just a single source? Is it related to multiple sources? So it, in some ways, is a forensic exercise. PFAS can be really complicated from a chemistry standpoint, but we can use that data to our advantage. You know, we can use all those different compounds that might be present in a mixture when these things are released. We can sort of use that like a fingerprint and then say, what does the PFAS that we're measuring right here look like? What does it look like maybe up gradient or in a background location? And can we make some sense of what those data look like? And that can be a hard thing to do, and it's a challenging thing to do, and it's one of the things that you really need a lot of expertise in understanding sort of the chemistry as well as sort of what happens to these compounds as they move in the environment.